video, we are going to learn about converting between moles, mass, and particles. So, the molar mass of a substance lets you convert between moles and mass. Molar mass is the gram in 1 mole of that substance. So let's look at this first problem. We have 10 grams of carbon, and how many moles is it? So we're going to do all of these with fence posting. If you haven't learned fence posting, then go back and watch that video before you look at this, otherwise it could be confusing. Here's the way that we want to go. We want to go from grams to moles. All right, and we can do that in one step using the molar mass. So we have 10 grams of carbon, and we'll set up a fence post. We have grams of carbon, and we want to get to moles of carbon. And just like with regular fence posting, the units go down and to the right, so that's grams. Now here's where you have your molar mass. Molar mass is grams per mole. Carbon, if you look at the periodic table, is 12 grams in 1 mole. So 12 grams in 1 mole. And then you are done. You simply plug that into your calculator. 10 divided by 12 equals 0.833 moles of carbon. Okay, so that's a conversion between grams going to moles. Now we're going to go the other way. Now we're going to start with moles, 3.5 moles of CO2, and we want to get to the mass. So again, fence posting, 3.5 moles of CO2, and you look up on the periodic table, carbon is 12, each oxygen is 16, and that's a total of 44 grams per mole. All right, we're going from moles to grams. Moles goes down and to the right, and we said that 1 mole of CO2 weighs 44 grams. So do that conversion, 44 times 3.5, and you get 154 grams of CO2. Okay, moving on. The next thing that you need to do is convert between moles and particles. So let's look at this. In this, for this kind of problem, you need to use Avogadro's number, which hopefully you remember is 6.02 times 10 to the 23rd. Okay, and once again, we are going to be able to do this in one step of a fence post. So now in this case, because you're just talking about particles, you're not talking about molar mass. So it doesn't matter really what you're talking about, what substance you're talking about. This could be 2.9 moles of H2O. This could be 2.9 moles of school buses. It could be anything. The actual identity doesn't matter, because all we're doing now is counting the number of things. So let's start this off. We have 2.9 moles, and we want to convert that over to molecules. Molecules. Okay, mole comes down and to the right. And no matter what it is, again, 1 mole contains 6.02 times 10 to the 24. All right. So you plug that in, you got 6.02 times 10 to the 24th times 2.9. And you get 1.74 times 10 to the 25, which is really what you should expect. So it's always good to go back and say, does this number make sense? All right, we're talking about 2.9 moles of H2O, and each mole contains an astronomical number of particles. So if you're talking about individual particles, you should have a really huge number, and we do. All right, now the reverse of this is going from a number of particles to moles. So we are given that we're starting with 5 times 10 to the 24 molecules and we are converting that into moles. So molecules comes down and to the right. And once again, we're using Avogadro's number, and so we will say 1 mole contains 6.02 times 10 to the 24 molecules. Okay, so let's see what we get. 5 times 10 to the 24 divided by 6.02 times 10 to the 24, and you get 0.8305, so 0.831 moles. All right. Now, this answer, again, if you look at it, should make sense, because you know that 1 mole is 6.02 times 10 to the 24, and we were given less than 6 times 10 to the 24, right? So you have 5 and 6, and so 5 divided by 6 should give you a little bit less than 1, which is exactly what we have. So your answer does make sense, which is good. Now, let's continue. The next step is to take this a little bit farther, and you're going to need 2 steps for these, because you're going to convert between grams and particles now. So we need to combine the 2 things that we just learned. So here you're going from molecules to grams. And we're going to do a fence post again. So 6 grams of H2O, 6 grams of water. Fence posted out. And like I said, we're going to need 2 steps this time. You can't go directly from grams to molecules. You have to go through moles. So I'm going to go grams to mole to molecule. So that's my unit map. Okay. Molecule. Grams H2O down and to the right. Moles down and to the right. And we can put in our conversion factors here. So here we need the molar mass. The first one is the molar mass, and if you look up the masses, you get 18. So 1 mole of water is 18 grams, give or take. And then we're converting between moles and molecules, so Avogadro's number, 6.02 times 10 to the 23rd. Alright, so let's see what we get. 6 times 6.02 times 10 to the 23rd, and then divide that all by 18. And again, we're ending with molecules, and so the number should be astronomical. And what we get is 2.01 times 10 to the 23rd, okay? Just as we would have predicted a really huge number, because you're dealing with individual tiny, tiny molecules. All right, now I've run out of space at the bottom, so I'm going to do this last question in the same space that we just had. Alright, so the last question is, what is the mass of 9.5 times 10 to the 23 atoms of neon? So, again, we're going to fence post. 9.5 times 10 to the 23rd atoms, so particles. And we'll make our unit map here. We can't go directly from atoms to grams to mass, so we have to go through moles. So moles, and then once we have moles, we can go to grams. So atoms down here, moles down here. Alright, so to convert between atoms and moles, Avogadro's number, 6.02 times 10 to the 23rd atoms is 1 mole of atoms. And then if you look up neon, which is what this question is dealing with, you see that neon is about 20.2 grams in 1 mole. Okay, so multiplying it all through, you have 9.5 times 10 to the 23 times 20.2, and all of that divided by Avogadro's number, 6.02 times 10 to the 23, equals 31.9 grams. Okay, so make sure you can do these. It is a basic skill in chemistry, and you're sure to see it on tests in the future. Thanks for watching.